Hello, my name is William Rook. I am dressed business casual, and I am ready to present on the low voltage DC distribution system. As for the agenda for this project, I will run through an abstract, project objectives, introduction and background, design approach and outcomes, technical details and results, timetable, Gantt chart, lessons learned, conclusion, and then finally references. This topic has been discussed all the way back in the 19th century when Westinghouse's AC power plant went up against Edison's DC power plant. In this project, I have researched and designed a DC distribution system for a home. Modern technology has allowed for DC conversion, which is not only possible for larger voltages now, but to be more efficient as well. The future of power distribution is DC, and through designing the DC system, I researched AC versus DC loads, DC distribution, leakage in AC houses, DC generation, and safety advantages of the DC system over the AC system. In the design process, AutoCAD was very advantageous to show a 3D model of the newer DC home and of the generation that went along with it. Throughout the process of reading this design project, I have found a proper way to show the DC distributed home model and prove why it is an improvement over the AC system we have in place today. The project objectives are to create an example DC home that could later be implemented in real life, produce a DC distribution system for homes both in rural and urban areas, prove the advantages in energy saving and safety for using DC over AC power, and all of these objectives will be complete throughout the length of a semester. The current war between AC and DC dates all the way back to the 19th century. Westinghouse advocated for us to use AC, and Edison challenged for DC. Westinghouse's AC plan won for one reason, and that is because of transformers. Transformers only work with AC because they require a time-varying voltage to function. There was no easy way to change the DC voltage until much later in time, temporarily making DC electricity inferior to AC electricity. The reason that changing the voltage is so important is because generation and power consumption happens at very low voltages. However, during transmission, higher voltages are very beneficial because less energy will be lost at those high voltages. So back then, AC's DC plan was to have power plants about every mile, which was not very practical. In current time, most electrical devices are powered through DC supply. Technology today allows for efficient AC to DC power conversion and DC to DC step-up and step-down conversions. The world's largest transmission lines even use DC today because over the long distances, DC actually has less energy losses than AC. DC is making a strong comeback, so we should plan for the future and realize the advantages of this DC powered distribution. Most electrical appliances use DC power, but the house is supplied by AC power. So when you look at your typical outlet, it will be supplying AC power. The problem with this is that we will have to use an AC to DC converter in most appliances to even work. Some of the appliances that are DC powered in your home include, but are not limited to, TVs, computers, fans, cell phone chargers, fluorescent lights, washers, dryers, and microwaves. Some examples of the sizes and energy saving percentages include a charger getting a size decrement of 20% and a 10% energy saving, a TV getting a size decrement of 10% and a 10% energy saving, and a computer getting a size decrement of 15% and an 8% energy saving. The multiple AC to DC conversions make the energy efficiency go way down. DC distribution has been known to be more efficient in power lines than AC even back in the 19th century. The only real reason AC won the current war was because transformers only work with AC electricity, and there was no efficient AC to DC conversion. The high voltage drop occurs across the AC terminal lines when their terminal's voltage is equal. The DC transmission line is free from inductance and hence no voltage drop occurs across the line. And at the same voltage, the DC transmission line has less stress as compared to the AC transmission line. Hence, DC requires less insulation compared to AC. Also, rural homes will require a lot more power line distance per house than urban homes. AC powered houses will leak energy. Even when everything in your house is turned off, an example of this is when you get back from vacation and your energy bill is still not even close to zero. This is because of standby power, which is used to maintain the AC powered applications in your house that do not actually turn all the way off. DC power would cut the standby power down considerably because the low voltage DC house could actually shut down and while you are away, making all the applications actually turned off and not using this standby power. When DC power is generated, it will not need to go through an inverter to change to AC power, so it cuts down on the energy losses through conversions. Most ways of DC generation are through renewable resources such as solar, wind, and hydropower, so it'd be an advantage for the environment as well. As an example, a solar panel produces direct current. The sun on the solar panel simulates the flow of electrons, creating current. Because of these electrons flow in the same direction, the current is direct. Safety is another huge advantage to switching to a low voltage DC distribution system. The low voltage architecture makes sense because it gets rid of the wall warts and charges, gets rid of the shock hazards and code restrictions, and gets rid of any electricity leaking from your house. Therefore, switching to this DC system could even save lives. It makes the design of the house much simpler too, so no more AC to DC converters all throughout your house. In order to complete the design of this project, I decided to use mostly research, and then I would pick the best components from each research section to either put in my design or be used to prove the advantages of a DC distributed home. Other than research, I was able to get some help in my design and model approach from 3D modeling in AutoCAD. The reason why I decided to go with this way of prototyping is because I needed a way to see what a DC home would look like conceptually. There was no need for any MATLAB, Mathematica, Multisim, or a real programming language because this was a conceptual design made using research. The AutoCAD drawing was enough to show the reader an outside design of the house. As for the inside of the house, it would look just about the same as an AC powered house you see today, so I didn't really see a real purpose of showing that. The performance parameters I used was a simple comparison of an AC and DC powered house. I was able to gather research from a multitude of articles displaying the energy efficiency of AC and DC appliances, consumption of power, as well as the energy efficiencies of the AC and DC power lines over different distances. I was able to rate advantages and disadvantages through these performance parameters. As for the design outcomes, I decided on a renewable DC generation system, and more specifically solar panels, because they fit very well on the roof of a house, and the efficiency of these solar cells are becoming increasingly more researched and more efficient every year that we research them. I decided that the DC to DC conversion was enough from generation to transmission and distribution, and into finally the consumption portion that all homeowners and business owners use. Something that should be revisited is rural versus urban planning, because there is a huge difference in the length of line in between each house. So a rural area would have a lot more power line usage in between houses than an urban or a city house would be, or apartment. This also eliminates most of the AC to DC converters you would see in a house, as well as energy leaks. This is a beautiful 3D model of a low voltage DC generated and distributed DC smart home. On the roof of a house, there is a grid of solar panels used to provide the DC generation. Inside the house, most of the AC to DC conversions that you normally see are no longer there, and so therefore will not take up that unneeded energy on the electricity bill. The home does not look very different from a typical home you see today, but it is more efficient and can even save the homeowner money on his power bill. This is a great flowchart of the different DC generation powers, such as hydropower, wind power, solar panels, and even other renewables such as human-powered generators. This generated power will then go through a DC to DC converter and put into a multiple DC converter, and then finally it will run through a DC bus, which also has a backup battery source hooked up to it, into a feeder bus, and then finally running all of the different applications that you use inside of your own house. The results of this design project would be a happier energy supplier and a happy energy consumer, an increased energy efficiency, decreased application size, and simpler homes. Some discussion questions I had are, should there be different levels of DC voltages through the house? How possible is it for a home to be completely supplied by their own renewable generation? And how long would it take to complete an entire DC distribution redo? Did this project meet its objectives? Well, I think so. The DC home design can be implemented in real life. The DC distribution system is different in rural and urban areas, and also there's room for improvement on that part. There are clear advantages in energy saving and safety for using DC over AC power, and all of these objectives have been completed throughout the length of this semester. This is my timetable and Gantt chart. So as you can see, the project proposal took quite a while to do, as well as researching this project. And then finally, I got to designing on the generation and designing the means of distribution, and then finally I'm making my presentation this week. What I learned from this project is that it would be very time consuming and expensive to change all the AC transmission and distribution over to DC. However, it would be more efficient and save energy and money from being wasted in the current AC system than the current AC system. I would also recommend that in situations of very long transmission lines, we should use DC power. If they are shorter transmission lines, I think it would be acceptable to keep the AC distribution system expense-wise. I do not see any commercial value in this project, and it is not very marketable considering it would be a full-scale redo of the current distribution system we have in place today. However, this project should push for when we replace the old power lines and design new homes, DC distribution systems, low voltage DC distribution systems should be implemented. In conclusion, through the research of AC and DC loads, DC distribution, leakage in AC houses, DC generation, and safety advantage of DC systems, I have picked a great design of a low voltage DC distributed home and proved why it would be more beneficial than the AC system we have in place today. Through the use of AutoCAD, I was able to display a great example of what a DC house would look like, including the generation and the DC buses and appliances in the home. When the next update for power lines is up for discussion, a DC system absolutely should be implemented. This is my last slide and also my references slide, and these are all the different references that I used to research this project. Thank you, and I hope you have a great summer.